this video, we are going to learn about the introduction to Laplace transform. Laplace transform is a method to transform an equation from time domain to another equation which is S domain. Okay, we can see here this is a normal differential equation and it's a function of time. You only see t over here. When we transform it using Laplace transform, we get another equation which is just a function of s. You only see s here, there's no t. Why do we use Laplace transform? One of the major use of Laplace transform is to solve differential equation. Okay, this is a differential equation and we can use a classical method, a normal method to solve it and we'll get this solution. But this classical method is very complex and very difficult to do. The alternative way is to use Laplace transform. We can use Laplace transform to transform it to S domain function, and then we use algebraic manipulation to get a revised transform. We just find this in terms of IS, and then we do inverse Laplace transform to get the solutions. Okay, even though it involves 3 steps over here, all these 3 steps are actually very simple steps. So this is much easier to do compared to this one difficult step. Okay, so that is why we use Laplace transform to solve differential equation. Okay, so it involves these 3 steps: taking the Laplace transform, do algebraic manipulation, and do the inverse. Okay, one more thing I want you to note, that in Laplace transform, in the time domain function, we usually use small I. Okay, all the variables like I or F, we use small lowercase, and in transform you use uppercase to differentiate it. Okay, yeah. How to do Laplace transform? This is the proper definition. Okay, this is the function ft when we transform it. So this is the time domain. When we transform it, we get it in Laplace domain, okay, which is capital F. And you can see we use lowercase and uppercase, and this is time domain, this is S domain. Okay, but don't worry, we won't be using this equation. You don't need to use it. We will, in fact, instead to do Laplace transform, we will use a table, because if we use this equation and we apply it to normal functions, common functions, we'll get a very good, a nice pattern. Okay, like this. Okay, like this, we'll find a pattern. So based on this, we can easily do transforms whenever we want to do. Okay, so I'll show you some examples here. Let's say I have a time domain function, ft is t cube. Okay, and I want to find the Laplace transform. To find the Laplace transform, I just go to the table and I look for this form. To take transform of this function, we look in the table, the row which has this form t to the power something. So this is the row. Okay, so this is the row, and the transform will be, and the n over here is equals to 3. Okay, you can see your n is 3, t to the power 3. So the transform is t 3 factorial over s to the power 3 plus 1. Okay. What is 3 factorial? For those who are not familiar, this exclamation mark here, we call it factorial. Okay, which means 3 times 2 times 1. Okay, if you put 5 factorial, it means 5 times 4 times 3 times 2 times 1. 10 factorial with 10 times 9 times 2 times 1. That's the meaning of factorial. And in your calculator, you don't need to multiply all. Okay, this is simple. 3 times 2 times 1 is 6. But if 5 factorial or 6 factorial, there's in your calculator you'll find this symbol. Okay, you just need to put this and it will give you the value. Okay, okay, now let's look at this. Okay, this is not second row. Update it later. It should be the 4th row. Okay, now for this, e to the power minus 2t. So we see here it's similar to this form, e to the power minus something t, and your a is 2. So the transform is 1 over s plus 2, which we see here. Okay, same thing, this is cos 10t. So we see here it's similar to this form. Your b is 10. So just change b to 10 and we get this. Okay, so that's all to do. Transform using the table. It's very simple.